Hello, everyone. Today we're going to talk about coordinate proofs and apply them to quadrilaterals. So the first thing I'm going to point out to you is actually I'm going to scroll to page 21 and 22 in your packet. So on page 21 and 22 is this great chart that helps you see the different ways we can improve certain things in coordinate geometry. So you'll see underneath the parallelogram, I can show that the diagonals bisect each other by doing two midpoints. I can show that both pairs of opposite sides are congruent by doing four distance formulas. I can show that both pairs of opposite sides are parallel by doing four slopes. Or I can show one pair of opposite sides are both congruent and parallel by doing two distances and two slopes. Now, obviously, if it doesn't tell me how to do it, I'm going to do the two midpoints because I think that's the easiest and the least amount of work. But again, any one of these four methods would definitely work in the circumstances. Now, to prove that something's a rectangle, I need to first prove that it's a parallelogram and then show that consecutive sides are perpendicular by doing four slopes. So if I'm asked to prove something's a rectangle, I'm actually going to do the four slopes because the four slopes shows it's a parallelogram as well. Now I could do the two midpoints and then to show it's a parallelogram and then do for the two diagonals to show they're congruent. It's entirely up to you. So a rhombus, again, I want to first prove it's a parallelogram. So I would do any of the methods above. So again, here, I might want to do the four distance formulas because that shows me it's both a parallelogram and a rhombus. So I can show it's all four sides are congruent. Or I can show that the diagonals are perpendicular. So that would require two slopes plus proving its parallelogram. So a square, again, I need to first show it's a parallelogram, and then I can show that it's a rectangle with congruent adjacent sides. So that would be, actually, that would only need to be, it would be six distances because I need to show that the two diagonals are congruent. So, and then prove it's a rhombus with a right angle. So there I could do the slopes or I could do any kind of combination. Trapezoid, I actually only need two slopes for a trapezoid because to show it's a trapezoid, I only need one pair of opposite sides parallel. I do not need to show the one pair of opposite sides is not parallel. I do not need to do that. So please cross that out. Isosceles trapezoid, I need to show it's a trapezoid and that the non-parallel sides are congruent. So that's two slopes and two distance. Prove that it's a trapezoid and the diagonals are congruent. So that would be two slopes and two distances, but the other two. Kite, I need to show two pairs of consecutive congruent sides. So that's four distances. So that's how I can prove things. You have this chart. I just wanted to outline it for you. And now we're going to go up here to today's examples. Our first example is actually going to show a theorem. And our theorem is going to, we're going to prove the theorem before we write the theorem. So this is a mid-segment of a trapezoid, which is the segment that joins the midpoints of the non-parallel sides. So for this proof, I'm going to use coordinate geometry. So I'm just going to sketch the graph. So A is at 1, 1. B is at 7, 1. C is at 3, 5. Oops, and actually we should flip-flop these letters. It should be C is at 7, 5. And D is at 3, 5. So there's my trapezoid. And I want to show that the mid segment is the segment that joins the midpoints of the non-parallel sides, show by coordinate proof that it is a trapezoid. So to show that it's a trapezoid, I really only need one pair of parallel sides. So you can see from my little sketch here that AB should be parallel to CD. So I'm going to use the slope, which is change in y over change in x, or y2 minus y1 over x2 minus x1. Whenever you're doing a coordinate proof, you should write the formula out. And then I need to identify what side I'm finding the slope of. So AB is what I'm finding the slope of first. So that's 1 minus 1 over 7 minus 1, which is 0 over 6, which equals 0. And then CD is 5 minus 5 over 7 minus 3, which is 0 over 4, which also equals 0. Therefore, which is these three little dots, AB is parallel to CD. They have the same slope. And that implies that ABCD is a trapezoid. It's a quad with one pair of parallel sides. So now part B, find the midpoints of the non-parallel sides. Label AD as E and BC as F. I flip-flopped it because I want it to be trapezoid ABCD. So AD is going to be E, BC is going to be F. So our midpoint formula is x1 plus x2 over 2, comma y1 plus y2 over 2. So pause and find the midpoint, and then find the slope of EF. Okay, so I found the point E to be 2, 3, and the point F to be 7, 3. I then did the slope of EF, which gave me 0. Therefore, I know that AB is parallel to CD, which is also parallel to EF. They have the same slope. So now I want to find the length of AB, EF, and CD. So again, here you're going to use the distance formula, which is x2 minus x1 squared, quantity, plus quantity y2 minus y1 squared. So I want you to pause and I want you to find AB, EF, and CD. Okay, so AB is 6, EF is 5, CD is 4. So you may notice that if I do AB plus CD divided by 2, that equals EF. Because 6 plus 4 over 2 equals 5, or the average of CD, AB and CD. So our theorem is the midsegment of a trapezoid is parallel to the parallel sides and its length is the average of the parallel sides. So, number 2, the vertices of quadrilateral ABCD are those. Show that it's a parallelogram. So I want you to pause and show this is a parallelogram. Remember, our sheet gives us lots of ways. Okay, So you can see that I did number two different ways. You don't have to do both. I did two different ways. So the first way I did is I did the midpoint. So I wrote my formula, x1 plus x2 over 2, comma, y1 plus y2 over 2. I found the midpoints of the diagonals. So one diagonal is AC. It gave me a midpoint of 5, 1. The other diagonal is BD. It gave me a midpoint of 5, 1. I then wrote, since AC and BD share a midpoint, therefore they bisect each other. So ABCD is a parallelogram, a quad whose diagonals bisect. The other way I did was the slope. So the slope is delta y over delta x. So I found the slope of all four sides. So the slope of AB is 3/2, BC is -1/2, CD is 3/2, AD is -1/2. So therefore AB is parallel to CD and BC is parallel to AD. They have the same slope. So ABCD is a parallelogram. It's got two sets of parallel sides. So one more proof to do. This says quadrilateral math. Prove that math is a rhombus and prove that it's not a square. So I'm going to choose to prove that it's rhombus by doing the distance formula. So I'm going to do the distance formula on the four sides. Okay, so I showed the distance of all the sides all equal 5. Notice I showed the original distance formula and I substituted each one. I then said that MA equals AT equals TH equals MH. They have the same length. Therefore, math is a rhombus. It's a quad with four congruent sides. Now, to show that it's not a square, what I need to show is I need to show that either the diagonals aren't the same length or I need to show that there's no right angle. I'm going to choose to do the slope, which is delta y over delta x, and I'm going to find the slope of two adjacent sides to see if they are perpendicular. So I'm going to do MA. The slope of MA is 1 minus 5 over 1 minus -2. So that's -4 over 3. And then I'm going to do AT. So, because those are next to each other. So AT is 5 minus 5 over 3 minus -2. That's 0. -4/3 and 0 are not negative reciprocals. Therefore, MA is not perpendicular to AT, and math is not a square. So that's the end of our video today. If you have any questions, please bring them to class.